Hello everyone, my name is Emily Null and I will be presenting to you this paper which is about the visualization of decision pathways towards reaching environmental impact targets at the early design stage. Environmental impact targets expressed, for instance, in terms of global warming potential or greenhouse gas emissions are increasingly found in different labels and rating schemes. However, from the point of view of decision makers, it's rather difficult to anticipate the impact of their design decisions from the conceptual design stage and to see which decisions may compromise or help achieve a given target. So this is what we're specifically interested in looking at here. What is reported in this paper falls within a larger research project called Specific Environmentally Conscious Targets for Urban Planning. I invite you to read this journal paper which describes this project. Here I'm going to quickly focus on the topic of this conference paper, which is how to provide meaningful and interactive visualization of a large data set to help decision makers. So here we're focusing on the decision tree technique, which is said to be one of the most suitable methods to show the impact of parameters here, decision or design parameters. So what we're looking at specifically is, say we have an urban site with different zones in which we can construct different type of buildings. At the early design stage, we might only know the maximal constructible volumes, but we don't know what will be inside that. So the approach was to generate a series of building design variants for each lot. Here we're going to focus on the small one. And use the set of over 13,000 scenarios that were generated for this lot to look at the results. So basically we have a series of variants. Here you can see 4 examples where the building shape is varied, the window to wall ratio is varied, the type of construction, etc. are varied, and we compute the global warming potential of these different variants. Then what we do is from this data set, we apply the a decision tree classification algorithm to produce a visualization that will that will organize the data in this way. So we will have different nodes which correspond here to our variable parameters, for instance, window to wall ratio. And we have different branches which are the different possible options that we have previously defined for each of our parameters. For instance, for the window to wall ratio, we have 3 possible options. And so these will be our branches. And then we have, in the end, the classification of the scenario. In this case, the classification corresponds to whether or not we are above or below a given GWP target that we previously imposed or defined. So on to results already. So what you see here is the beginning of a decision tree that we obtain when we apply a target of 20 kilograms of CO2 equivalent per meter squared per year. So first we see that we have about over 7,000 scenarios in our data set that comply with this target, so that are below this value. And what we also see is that the root parameter, so the first parameter that appears in our tree, is corresponds to the construction of the horizontal elements. So this is the algorithm has determined that this parameter is the one that best discriminates between the complying, non-complying scenarios, such as to have the most compact tree as possible. Now, if we, this is an interactive online visualization. Here you see only screenshots, but if we open this tree, we can investigate further. So here the user has opened the concrete construction branch and the timber frame construction. And we clearly see that if we follow this path, if we combine to that selection a district heating system, given the the characteristics behind, we could quickly reach a point where we have almost no more complying scenarios left. So this would be seen as an unfavorable option, while if we open up here our timber frame construction, well, this is a more favorable option, as we can see here from the larger amount of complying scenarios. So by investigating this tree, we can start to see which are the strings of parameter values or of decisions that will lead to favorable results and that will maximize our chance of respecting our given target. So this path here would be seen as a very favorable pathway, where when we reach this level, regardless of the values for the other parameters, we're almost certain that our scenario will be complying. What happens if we play around with this target and we change this value? Well, here what you see is, again, the same tree on the left for the 20 kilograms target. And if we increase this target by 2 kilograms, then we see that we have a larger amount of complying scenarios. So directly, we have a much larger design freedom, which is to be expected. We also see that the root parameter is different. So here, the heating system is seen as the most discriminating parameter. And so this tree can also be, as I said, investigated online. So we have this web app where we can play around and open up the tree. Here what we can see, for instance, is that as soon as I reach the 3rd level, if we combine a biomass boiler with wooden horizontal element construction, all of our scenarios that are left are complying. So this is a very favorable path that leaves a large freedom for all the other decisions that will come. So to conclude, the decision tree visualization allows us to see the favorable or unfavorable decision pathways with respect to the environmental target that we have set. It allows us to anticipate the implication of the different design decisions that might be taken throughout the design process. And so we can see the linkages between these parameters that are usually treated separately at different design stages and by different professionals. So this visualization can be used as a communication support tool in an interdisciplinary team. And it highlights the importance of making coordinated decisions by showing us that early stage and later stage decisions should be looked at together. I thank you for your attention. I invite you to read the paper and don't hesitate to contact us.